I think
I thought we determined we did the same one.
it's a Knowlton.
Knowlton?
I did a piano, so
You're talking about my mom.
I want to.
Yeah, but it's also
I've had Knowltons before.
We have
Have you ever been a narrator before?
What?
They like to say YouTube, but like weird.
Anyway, I thought it was like guys.
Just gonna change it so it sounds cooler.
I'm gonna change things up today.
Yeah.
Yeah. I think we have.
No, I was talking about
I just thought it was.
Mr. Davis, have you ever been a narrator before?
Narrator?
How it was
For, like, a play or something?
It's about like
No?
a memory.
I feel like you'd be good at that. Beat Boys.
I was.
Oh.
Oh god, you remember that in Summertime?
He's like, how do you pronounce this?
Is that an actual?
He did that in every hour. That's
Oh, Josh gonna be.
And he was so like,
I already upset
he
you.
was so
Yes.
passionate about it. Literally.
Literally, you're so passionate about it.
So, literally, like, you do nothing.
well, kinda, so okay. So I'm gonna do some examples here. This Derivagrals is a made up word. Surprised no one else uses it. I think it's a pretty cool made up word, but
Yeah, I would think of the word Derivagrals would be a really cool one to make up.
So weak. Sorry.
okay. So I don't. This is one of those like. I'm always torn. Like, do I just give examples right away, or do I give like the actual process? Because I think if I give the process, it's really confusing until I give examples. So then I'm like, why am I doing that? This is what I do in my head. So this is the process, though. So they'll give you an equation where they say f of x is the integral of g. And then they'll ask you to find f prime of x. So if f of x is the integral, imagine going up a level, and then you're asked to take the derivative. See how you kind of end up right back where you started? There is a chain rule piece to it, though. So what this would be, so this g right here is going to get integrated by this sign, and then differentiated. And when I say that, people get confused, so I was trying to derivative it. It'll end up back at g of t. You still need to use the a and the b. And keep in mind that the a and the b haven't really been derived yet. They haven't been taken, the derivative of a and b have not been taken yet. So we really took the integral and the derivative of the g. The a and the b never get integrated, but they do need to be differentiated. So that's the way this looks at the end of the day. Is you plug in the top number, but then you multiply by the derivative of what you plugged in, minus you plug in the bottom, and then you multiply by the derivative of what you plugged in. I'm quite confident that right now you're thoroughly confused. And that's fine.
I get it. Because I tried to do this con and it was just not working out.
Wait, do you actually get it, or are you like sarcastically saying it?
No, like, isn't it like a number and an x? Where a and b
Yeah, most of the time
it would be like 2x, so then the derivative of the, let's say the 2x was for b, you just put a times 2.
Yeah.
Yeah, I looked at this and I was like, yeah, let's do the next one.
So Shield's like miles ahead of us, as we have to often do in this class. We have to catch up to Shield, get to where he is.
Yeah, I'm going to lowest grade in the class.
So this is what it would often look like. Find d over dx of the integral from, let's say, 3 to 4x of t squared times dt. Something like that. And the process is pretty simple. It's really confusing, like, just what's going on. So I call it a derivagral because you're taking the derivative of an integral. And I like Googled surely other teachers somewhere are calling this a Derivagrals, but no. So I guess I'm weird. So the derivative and the integral piece cancel out regarding the t squared. So you end up with just t squared here. The 3 and the 4x are still there. And then what you do is you plug in the top number, which is 4x in this case, in place of the variable. So I put the 4x in place of t, which will make it 4x squared. And then I multiply by the derivative of what I just plugged in. It's like a chain rule piece. So when I plug in the 4x, then I multiply by 4. And then I repeat that, and this is the most common setup that you'll see. So when I plug in the 3, I'm going to get, 3 squared. But then I'm going to multiply by the derivative of what I just plugged in. And usually, I don't know about usually, very often this is a constant. And what's the derivative of any constant? It's 0, which makes this piece just go away. And this is a valid answer, like it is. On a multiple choice, they might go, okay, well that's 16x squared times 4, so it's really 64x squared. Simplifying is not what I'm worried about. It's, the actual process.
What if you try to simplify it wrong on the gateway?
I would just leave it on the gateway because you have nothing to gain by simplifying, and you might lose. No style points, so word is. Let's say f of x equals the integral from cosine of x to e to the 4x of the square root of t times dt. And they say find f prime of x. Is that a Derivagrals? It is, right? Because this t is going to get integrated and then differentiated. So they're asking you kind of to, they almost thought they offset each other, but then you got this, the a and the b here to worry about. So the derivative and the integral piece cancel out as far as the square root of t goes. So you're going to integrate the square root of t and then you're going to take the derivative of it. So you end up with the square root of t. But you still have to plug in the cosine of x and the e to the 4x. Is that part okay, what I'm doing so far? And then you plug in the top number, or the top function in this case, so it becomes the square root of e to the 4x. And then you multiply by the derivative of what you just plugged in. Minus. Plug in the bottom function, so this will be the square root of cos x times the derivative of what you just plugged in. So what's the derivative of cos? Negative sine of x. And that would be your answer, yeah.
I thought e to any power is just, the derivative is just e to the power.
Oh, crap, that's not times 4. My bad. Totally screwed that up. What's the derivative of e to the 4x? E to the 4x times 4. I just, ignored the whole e to the 4x part. Sorry. Thank you. You said you were really confused. Does that make more sense then?
Yeah.
Okay. Yeah, my bad.
This is why Joe was ahead of us.
Yeah, see, we're all just trying to catch up to Joe's world. Alright, let's say f of x equals the integral from 4 to ln of x of t squared plus 4t times dt. And they say find f prime. Am I looking at a Derivagral? I am, because they're telling me you got to integrate this. This is our function here, the t squared plus 4t. You got to integrate it, and then you got to take the derivative. So as far as that goes, you end up right back where you started, t squared plus 4t. And then plug in the top number in place of the t, or the top function in place of the t. So you're going to have ln of x squared plus 4 times ln of x. And all of that will get multiplied by the derivative of what you just plugged in. So multiply by what? What's the derivative of ln of x? 1 over x. So people have trouble with this sometimes. When there's two terms, it starts to get a little more confusing, I think. So you got to make sure you're plugging in the ln in both places. And then you need big parentheses around this because the 1 over x needs to be multiplied by the whole thing. Where if you didn't put those parentheses, you'd just be multiplying the 1 over x by this second part, you know? So make sure you have the whole thing there. Minus, and I'm going to write it out, but I don't really need to write out this second part because what am I going to multiply by at the end of it? I'm going to multiply by 0. But just for the sake of completion, you would plug in the 4, and then you'd multiply by the derivative of that 4, which is 0. So this whole piece goes away in this case, and it very often does. And that'd be your answer. And I would just leave it. I wouldn't worry about simplifying it unless it's multiple choice and you're forced to.
Yeah, that's
Not that bad. It would just be like ln squared of x plus 4 ln of x over x is probably what they would do. Be okay. Questions on that one though? Or don't care about the simplifying part, but any others? Let me give you one. Find a hard one on your worksheet. I think we're doing harder ones than are on the actual words. Alright, let's say the integral from cos of x to 2x of 2t to the third minus t squared plus 4t times dt. That's about as annoying of one as you would probably ever get. And then find f prime of x. So go ahead and try that. So this piece here, kind of where you're starting, and then that piece is going to get integrated, but then differentiated, and you're going to end up right back where you started. And you still have to worry about the cosine of x and the 2x. So then you're going to plug in 2x to all those t's. And multiply that entire piece by 2. Because that's the derivative of the 2x. Two mistakes people make here is they forget to put the brackets, or the big parentheses, so then you end up just multiplying that by 2. The second mistake is people start trying to multiply by the derivative of this. But we already took the derivative of that. We integrated, took the derivative, and went up right back where we were. So make sure you're multiplying by the derivative of what you plugged in. And then minus, I gotta go down here because I'm gonna run out of room. So it'll be 2 times cosine of x to the third. Minus 2 times cosine of x squared plus 4 times cosine of x. Times negative sine of x. Don't worry about simplifying it. How many got to that? Yeah, what's up?
I thought just sine of x was.
The derivative of cos is negative sine.
Oh, okay.
The integral.
I thought, yeah, I was thinking.
Yeah.
That's not right.
What?
Negative 2 in front of cos x squared. It should just be negative.
Oh, 2 for some reason. Yeah, thank you. There should not be a 2 there. You guys see why? I screwed up and put 1 accidentally, but thank you. You can leave it like that, yeah.
Do you want to simplify that?
So there's one situation where you can't, and that's what I'm going to bring up now. But it'll be simpler. So let's say f of x equals the integral from x to 3x of t squared. Find f prime of 2. So now you got to do the process, and you're going to get, at the end of the day, at the end of the process, you have all x's, right? Like at the end of this, we had, the only variable left was x's. So then what are you going to do with that 2? Plug it in for x, and you'll end up with an actual number at the end instead of an expression. Yeah.
Should be dt.
Yes. That was a t. Does it please you to correct my mistakes after I use the word that it's not like revenge?
Think about it like that. Say,
So this is actually the fundamental theorem of calculus 2.
Wow.
Which sounds way more impressive than Derivagrals, but I went with Derivagrals anyways. So that when there's the 10 things on the gateway, there'll be one of these on the gateway. Two. And one, yeah. One is just like doing a definite integral. Yeah.
We know how to do the fundamental theorem of calculus, and we've only been in it for half a year.
Yeah. Wait, you have no idea how to do what? This?
no, I don't know how to do it.
Oh.
Josh, did you swear the 3?
That's crazy.
What'd you get?
Let's be an adult.
104?
An adult.
What'd you get for plugging 2?
What?
What'd you get for plugging 2?
Legally, to the government, I'm going to be an
Right, that's
adult.
what I plugged into. Okay, that's why I'm saying I did something.
Okay. So this t squared, it's kind of your base. It's going to get integrated. It's going to get differentiated. It's going to end up right back at t squared. You still got your 3x. You still got your x. So I'm going to plug in 3x, then multiply by 3. Minus, and why am I multiplying by 3?
This chain rule.
It's the derivative of what you just plugged in. It's like a chain rule thing. Minus plug in x, multiply by the derivative of what you plugged in, which is 1. And then plug in 2. So you can simplify first and then plug in, or you could plug in and then simplify. I always think it's easier to plug in and then simplify, but that's up to you. So I'm going to go 3 times 2 squared times 3 minus...
You wrote 3 times 2 cubed.
minus 2 squared times 1. So 3 times 2, 6. 6 squared, 36. 36 times 3?
108.
108. Minus 4. Did you say you got 104? How many had 104? Okay. Why did you think it was wrong? It just seemed like a weird number.
Yeah, oh.
Fell off. I mean, I just made it up. Are we good? Seem alright? Yeah, what's up?
I got
32 here. Did you get that?
Did you forget to plug the 3 when you did the derivative of 3x? That's what I did, and I got 32. Maybe I just...
What'd you do?
You know, like, just the 3x, you gotta also multiply by 3. That's why I squared 2.
Did you figure out what you just did? You just got it. Do you have like the 3 here though?
I have all that. It's just when I did the second step, I squared the 2 before I multiplied by 3 inside.
Oh, gotcha. So just remember parentheses for yeah. Good? Any other issues, questions? Okay. So, I have this, which is, practice of today's lesson. There's 20 of them. You do not
This is gonna be
have to do all 20. Unless that you have to in your brain.
my brain.
Yeah, I mean, I certainly don't think it's a bad idea to do all 20.
No.
I hated busy work in school, so I try not to get busy work.
The problem is this is the only class I ever have homework in. I don't do my team while I do my team homework, but not until about a week before the project. And we only have 10 days to do the last project.
He changed it for some reason.
You're all set now?
What?
You're good now?
Yeah. I'm set. I can
Why did you say that?
So then this is the review packet, which has 41 questions. This is not mandatory, but it has all the stuff that's going to be on the gateway on it. And you have Friday, Saturday, Sunday, so you have some time. That's what's going to be on the gateway. We will do a practice, like dress rehearsal gateway on Monday. Check it over, get that hopefully all squared up, questions answered. Gateway will be Tuesday and Wednesday. Yeah. So if you want to be eligible for more than one attempt at the gateway, your con is due before we started, which is Tuesday. So it's due Monday then. Or it's due Tuesday before class starts.
Yeah.
Really.
I'm definitely doing it Tuesday before class starts.
There's like 20 sections. I don't think I'd wait that long.
No, I've got like 15 of them done.
Oh, do you? Oh, yeah.
A lot.
There's a lot. Is it 20?
No, I guess like 10.
Yeah, it's probably pretty
Really?
low.
A lot of them are like.
I just like the ones that are fundamental theorem or average values.
Do you need the other one for Jacob too? Like, I need the one I just handed out for today.
Yeah.
Let me just give it to you. Okay.
Should we practice writing the constant one?
What do you mean?
Never mind. That was a different question.
Yeah, we're talking about this.
No. The times 0. Should we practice writing this side out?
That's up to you.
Yeah.
Yeah.
That's what I'm saying.
Okay. That was stupid.